Fourier transform of the triangular pulse g of t in figure P3.3 is 3.3-3a is given by g of f 1 over 2 phi f whole square times e power j2 phi f minus j2 phi f e power j2 phi f minus 1. Use this information and the time shifting and the time scaling properties to find the Fourier transform of the signals shown in figure 3.33b, c, d, e, and f. Okay, initially we have this one, that is g of t. For that one, the Fourier transform is provided. So using that, we have to find out the Fourier transform for this, this, and this, and this, and this, all the parts. So a part is already provided. So if we go ahead and write the Fourier transform for the a part, that is Fourier, can also mention here, Fourier transform of a signal g of t is g of f given by g of f is equal to 1 over 2 phi f whole square e power j2 phi f minus j2 phi f e power j2 phi f minus 1. Okay, this is what provided here. So using that, we have to do the b, c, d, e, f part. Now let's look at the b part. If you notice the b part, here we have a part and here we have the b part. B part is basically the time reversal. If you put minus t, like here we have g of t, if you put g of minus t, you will get this, because this is just flipped around the y-axis. So to do that, we can say that g2 of t is equal to this is actually g1 of t, because initial was g of t and this one is g1 of t. So we can say that g1 of t is basically equal to g of t time reversal. Time reversal, actually we can put g of minus t here. g1 of t is g of minus t. So now we have to find out the Fourier transform. So Fourier transform of g1 of t is actually finding the Fourier transform of g of negative t. Okay, which is equal to the g of f. Now let's go ahead and find it. So for this one, what we have to do is we have to plug minus value for all the f, because here we have this one t right. When it's t is positive f, when it's negative t, the Fourier transform should be negative f. So we can write Fourier transform of g1 of t is basically you take all these values 1 over pi f square. For the 2 pi f square, I keep it as positive, because when you square a negative number, it's going to be positive anyway, so you don't have to change the sign for this. And other than that, here we will have e power j 2 phi f, and since we have f right here, we put a negative for this. And then here we have, if you notice here, j2 phi f, so this f is going to be negative f, so negative, this one going to become positive, so that one positive j2 phi f right here, and then e power, And here also we have an f right here, so we had to put a negative for this, j25 f, the minus 1. Okay, that is the answer for the B part. And for the C part, if you look at this, if we shift this A 1 unit to the right, and then B also 1 unit to the right, A 1 unit to the right and B also 1 unit to the right, we will get this shape. To shift this one 1 unit to the right, what we do, we put like -1. So G2 of t is basically G of t minus 1 plus G1 of t minus 1. If you do that, you can get this thing. Okay, I'm gonna use a different color for this because I don't want to mess up with this. So first of all, let's try to find out also, like this is true for this, then the Fourier transform also basically the addition of these two. So f of g2 of t is basically f of t, I mean Fourier transform, not f of t. Fourier transform of g2 of t is Fourier transform of g of t minus 1 plus g1 of t minus 1. Okay, so what we can do here is we can do this individually. First we can find out the g of t minus 1, then we can find out the g1 of t minus 1, and then we can add them together. So let's go ahead and find the g of t minus 1. F e Fourier transform of g of t minus 1 so when you have a shift by 1 unit, what you have to do is you have to just put this equation e power minus 25f, that's equal, this is equivalent to shift by 1 unit to the right. Okay, if you put a negative, that's 1 unit to the right. If you put a positive, that is 1 unit to the left. So here we want 1 unit to the right, so we put negative, and also where there should be a j as well, j e power minus j25f. And if you multiply that one with the Fourier transform, then Fourier transform of g of t, you will get g of t minus 1. So now we can write the whole thing, that is e power minus j25f, and the Fourier transform of g of t is right here, 1 over 25f square e power j25f minus j25f e power j25f minus 1. So we have to multiply the whole thing with this, and that gives us the g of t minus 1. So let's do that. 1 over 25f whole thing square times e power j25f minus j25f e power j25f minus 1. Okay, that is for the Fourier transform of g of t minus 1. Now we have to do the same thing for the Fourier transform of g1 of t minus 1. Fourier transform of g1 of t minus 1 is basically you put the same one, e power minus j25f, and here we have named this one g of f, so this is g of minus f. Okay, because we did a time reversal over here, so g, that is basically equivalent to this one. This is the g of minus f. Okay, now we have to copy the whole thing, so I'm gonna use a new page to do that. So first copy this. So I'm going to write again f of g1 of t minus 1 is equal to the first term, that is e power minus j to 5f minus j to 5f, that one multiplied by this whole thing, that is 1 over 2 pi f square whole thing square, and then multiply by e power minus j to 5f plus j to 5f e power minus j to 5f j to 5f e power minus j to 5f minus 1. Okay, that is g1 of t, Fourier transform of g1 of t minus 1. Now we have both of them. We have Fourier transform of g of t minus 1, and also we have the Fourier transform of g1 of t minus 1. So the Fourier transform of g2 of t is basically addition of these two. Fourier transform of g2 of t is equal to Fourier transform of g of t minus 1 plus g1 of t minus 1. Now we can go ahead and add them together. So initially we had e power minus 2 phi f 1 over 2 phi f square. Since it's common for this value is common for both of them. If you notice, g of t minus 1 also have this, the first two value, and g1 of t minus 1 also have the first two values same. So we can take it common for both of them to simplify this writing. And then for the g of t minus 1, this one is positive, this one is negative, and this one is positive. So you can write that one e power j to 5f minus j to 5f e power j to 5f minus 1. Okay, this is for the g of minus 1. And for g1 of t minus 1, we can put a plus sign here because we are just adding these two of them. And if we start, this is the starting point, e power minus j to 5f. Okay, I'm going to continue over here, plus j to 5f e power minus j to 5f minus 1. And that's the answer for the C part. Now let's look at the D part. Okay, I'm gonna do the D part in a new page. For the D part, if you look at this, what is the shift we needed? We had to shift this g1 of t 1 unit to the left, and then g of t 1 unit to the right. So for g of t, we had to do the same thing as we did before because we are moving 1 unit to the right. But for g1 of t, we are moving 1 unit to the left. So this time it's going to be t plus 1 when we are moving to the left side. So the equation for the g3 of t Fourier transform of g3 of t is basically Fourier transform of g of t minus 1 and then plus g1 of t plus 1. Okay, this is what we are going to have. So as we did before, what we can do is we can find the Fourier transform of these two values individually and then add them at the end. So first I'm going to find out the Fourier transform of g of t minus 1. That is basically you multiply the g of f value with this constant, that is e power minus j 2 phi f, multiplied by the Fourier transform of g of t. And the Fourier transform of g of t, we already know that it's e power minus j 2 phi f. That's the first value we have here. And the Fourier transform of g of t is 1 over 2 phi f whole thing square multiplied by e power j 2 phi f t, 2 phi f actually, not t, and then minus j 2 phi f e power j 2 phi f minus 1. Okay, this is what we had for the Fourier transform of g of t. Okay, now what we have to do is this is for the g of t minus 1. Now we have to do the g1 of t plus 1. Fourier transform of g1 of t plus 1 is equivalent to, so initially we have before, when we have minus 1, move 1 unit to the right, we have minus j 2 phi f. When we are moving 1 unit to the left, this is a plus j 2 phi f, e power j 2 phi f and then multiply by the Fourier transform of g1 of t, that is basically time reversal of g of f, that is g of minus f. So we can just write this again, e power j 2 phi f, and the Fourier transform of time reversal of f is basically, it was like the same, the first value is like the same, 2 phi f square, and we just replace the f value with negative. We keep it first one positive because we have a square here, and this one is e power minus j 2 phi f, and this one became plus, and then j 2 phi f e power, and this one became minus j 2 phi f, and then a minus 1. Okay, so that is the Fourier transform of g1 of t plus 1. Now we have the Fourier transform of g of t minus 1 and then Fourier transform of g1 of t plus 1, and if we add them together, that's the Fourier transform of g3 of t. We can write again f3 not Fourier transform of g3 of t is equivalent to Fourier transform of g of t minus 1 plus g1 of t plus 1. We found out both of them, we just have to add them together. So g of t minus 1 is right here, that is here. Also what we can do is we can take the first two term common for both of them, so that will simplify our expression. So we will have e power, here we cannot do that because we can take this 1 over 2 phi f square common, but if you notice, this is e power minus j 2 phi f, this is e power plus j 2 phi f, so we cannot take that one common, but we can take this 1 over 2 phi f square common. So I'm going to erase this and rewrite it. 1 over 2 phi f square common, and for the first one we are going to have e power minus j 2 phi f multiplied by e power j 2 phi f minus j 2 phi f e power j 2 phi f minus 1. And for the, okay, that is this one, and then we are going to add the other term, that is e power j 2 phi f, and in the bracket we are going to have e power minus j 2 phi f plus j 2 phi f e power e power minus j25f, and then minus 1. Okay, that's the final answer. So f of t g3 of t is equivalent to this. Okay. Okay, this is the final answer. Now we have done with the d part. Now let's look at the e part. So e part, if you look at this, we have this one. It's look like a square shape. The question we have to ask is like, can we combine this triangle and make this square? Yes, it's possible. How we can do this is, if you move this one half unit to the right, and if you move this one half unit to the left, this is what's gonna happen. Okay, let's say this is the graph we have right here. Okay, so initially we have this, and if I move half unit to the left, it's gonna be somewhere like this, right? And if I move this one half unit to the left, then you see that initially it was -1, so negative half here. And if I move this one half to, so it's going to start right over here, and the middle is going to meet at the same point, and it's going to end at right here, right? So it's going to overlap over here. And the thing is, if you look at each point, in the middle we have both of them 0.5, so when you add, it's going to meet right here. And if this is, like, for example, let's say this height is 0.25, then this height is 0.75. So if you add both of them, you will get a line like this. Like when you add both of them, you will end up getting a line like this, and that's going to make a square. Okay, that's the thing that you have to notice, that when you move half unit each of these, it's going to make it a square like this. Okay, if you understand that, then this problem become easy. Otherwise, some people do derivative and all the stuff. You don't have to do that if you understand it. So now what we have to do, we had to move g of t half unit to the right. So we can say, what is this one called? This is g4 of t. So we can say Fourier transform of g4 of t is basically Fourier transform of g of t minus half, because moving half unit to the right, g of t minus half, I don't, and then plus g1 of t plus half. Okay, so if you look at this one, this g3 of t, it's almost like that. We moved this g1 of t plus 1 and g of t minus 1. Okay, so what's going to be the difference is, it's going to be exactly the same expression, except instead of this j2 phi t, we are going to have j phi t. So if you put if you write the exact same expression with minus j phi t, and here j minus j phi t, and here e power j phi t, actually j phi f, e power minus j phi f here, and also e power minus j phi f here, and e power j phi f here. And if you put the other term as it is, it's going to be the answer. But we can go ahead and do it again. Okay. Hmm. Okay, let's do that. So first I'm gonna, as we did before, what we can do is we can find them individually and then add them at the end. So first I'm gonna do the Fourier transform of, let's write it over here so we'll have a lot of space. Okay, Fourier transform of g of t minus half. Okay, that is basically e power, if it's minus half, okay, here if it's minus 1 we had minus j25f. If it's minus half we are going to have e power minus j5f minus j5f, and if you multiply that one with Fourier transform of g of t, then we are going to get the Fourier transform of g of t minus half. So e power minus j5f, and the Fourier transform of g of t was 1 over 2 phi f whole thing square multiplied by e power j phi j2 phi f then we had a minus j2 phi f power f and e power, I guess, let me see. So j2 phi f e power j2 phi f 2 phi f minus 1, and that is it. That's the Fourier transform of g of t minus half. Now we had to do the same thing for the g of g1 of t plus half, that is e power j phi f multiplied by the time reversed Fourier transform of g of t, a time reversed, and here frequency reversed. Okay. So e power j phi f multiplied by 1 over 2 phi f square remains the same, and then here we had e power minus j2 phi f, and minus this one we can plus, then j2 phi f e power minus j2 phi f minus 1, and therefore we can finally express the Fourier transform of t4 of t which is equivalent to, here we can take 1 over 2 phi f square common, 1 over 2 phi f whole thing square common, and then here we will have this one e power minus j phi f multiplied by e power j2 phi f minus j2 phi f e power j2 phi f minus 1, and then plus e power j2 phi f, actually e power j phi f multiplied by e power minus j2 phi f plus j2 phi f e power minus j2 phi f minus 1. That's the answer for the, this one is what E part. Okay, now let's look at the F part. Okay, what do we have in the F? F we have amplitude scale by 1.5, and also we have time scale by 2, and also there's a time shift 1 unit to the right. We have to do all of them, so we can write it over here. T5 of t gives time shifting scaling and amplitude scaling of g of okay g phi of t. So if you look at that, that is basically we are doing all of that with g of t signal. We are shifting this one unit to the right and making it bigger. So 1.5 g, this is the amplitude scaling because we have 1.5 height, 1.5 multiplied in the front, and then if we have the time expanded, then it's 1/2. If it's shrinked by half, then multiply by 2. Okay, so this is 1/2 t, and shifted 1 unit to the right, so -1 here, and that is basically it. Finally, we can express it as 1.5 g of t by 2 minus 1. So Fourier transform of, we can find the Fourier transform of individual things. Like first we can find out the Fourier transform of g of t minus 1. That is basically we multiply g of t with this constant value, that's e power minus j 2 phi f, and then that one multiplied by the Fourier transform of g of t, and we can write that one over here, e power j 2 phi f 1/2 phi f square whole square, and then e power j 2 phi f minus j 2 phi f e power j 2 phi f, and then minus 1. Okay, that is Fourier transform of g of t minus 1. Now the next thing is we can find out what is t by 2 minus 1. So Fourier transform of g of t by 2 minus 1. When we have this one dividing over here, it's in the Fourier transform it multiplies. So you will get, if you multiply 2 times of Fourier transform of g of t minus 1, g of t g of t minus 1, then you will get this, you will get t by 2 minus 1. So what you have to do is we have to just grab this equation and multiply by 2. So 2 times, and I'm going to write this on top. So that is e power minus j 2 phi f, and then the bracket 2 phi f square, and then multiply by e power j 2 phi f minus j 2 phi f e power j 2 phi f minus 1. Okay, so we have done that. We have just one more thing to do, that is amplitude scaling. That is 1.5. We have done all of this, like half t minus 1. We have taken care of this until here. The final thing is we have to do the amplitude scaling. That is the final answer. So f of t, Fourier transform of g phi of t is going to be equal to Fourier transform to multiply this whatever we got by 1.5, you're going to get that. 1.5 times g of t by 2 minus 1. Okay, so when we do that, this number is gonna turn into 3 and others remain the same. So there's nothing much to do, like 1.5 times 2, or you can just do one more step to show that 1.5 times 2, and then others remain the same. E power minus j to 5f divided by 2 5f whole square, e power j to 5f minus j to 5f, e power j to 5f minus 1. Okay, like the final, you can show the final. I'm gonna have to create a new page to show that. But finally, what you're gonna have is Fourier transform of g5 of t 3 times e power minus j to 5f divided by 2 5f whole thing square multiplied by e power j to 5f minus j to 5f minus 1. And that's our final answer. Okay, this part is which one? This one is F. Okay, that's it for this video. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.